Right. Differential equations. That's all that means is we're trying to solve out an equation that has a derivative in it. So if you'll look, here's our derivative. dy dx equals cosine squared x minus 25x to the fourth. So if we want to solve this differential equation, all we need to do is find where it started and make it say y equals. The first step on that journey is to multiply both sides by dx. And remember, when you multiply by both sides on dx on both sides, you're multiplying everything on left and right by dx. That gives us dy equals cosecant squared x minus 25x to the fourth dx. And then integrate both sides. Okay, these are the steps that you're going to take. You're going to integrate both sides. Well, on the left, everything is a y. That's the variable that we've got. And so the derivative of dy, when you integrate dy, you're just going to get y. So there's my y equals. When I integrate on the other side, this cosecant squared, if you look at your trig list of derivatives, you'll notice that the derivative of cotangent x is negative cosecant squared x. So the derivative of negative cotangent x will be cosecant squared x. Okay? The other part there is at 25x to the fourth. So remember that we're going to have something x to the fifth. And so when you look for that antiderivative, just think to yourself, 4 plus 1 is what? That's 5. So 5 times what number is going to be 25? And in this case, it's 5. So 5x to the fifth. But we want the general solution, which means any solution possible that we can come up with. And that's going to be plus c at the very end. So there you go. There's a general solution to this differential equation. Not too bad, and something that we can handle. Well, what about over here on 18? We're going to start off with the same thing. We're going to multiply both sides by dx. And when you multiply the left and the right by dx, you multiply everything by dx. So what I have is dy equals e to the 6x minus cosecant x cotan x dx. And so to solve this, we're going to take the exact same steps that we took just a second ago. We're going to integrate both sides. And when you integrate the left where the y is, the only variable over there is y. So that's going to give us a y. And when you integrate the left, it's a little bit on the tricky side. Remember that e to the 6x, any e to the x, if you take derivative of e to the x, it's e to the x. So in this case, I'm going to have e to the 6x. But when I take the derivative of e to the 6x, I'm going to have e to the 6x times 6. So what can I do to make sure I just have a 1 left over when I get to my differential equation? I'm just going to divide by 6. And if you have a hard time with that, just run over someplace and go, okay, if I've got e to the 6x and I take the derivative of that, what's that going to be? Well, it's going to be e to the 6x times 6. So I don't need a 6 in front of my 6e to the 6x. I need a 1. So in order to get 1, what do I have to do? And in that case, I've got to divide by the 6. Okay? So that's where that guy comes from. All right. Now, what about this cosecant u cotan minus cosecant cotan? Well, if you look at your trigonometric derivatives, you're going to see cosecant x cotangent x, and you're going to see that the derivative of cosecant x is equal to cosecant x cotan x. And then lastly, since we want the general solution, we want every possible solution, we're going to add a plus c. All right, last guy here. Let's look at this guy. We're going to start off the same way. We're going to multiply everything by dt. So we're going to multiply everything over here by dt. And on this one, I'm going to spread it out just a little bit. I have dy equals, I'm going to distribute dt, so I'm looking at two different parts. 8 square roots of t dt plus 6 cosine t e to the sine t dt. And now when I integrate both sides, what I'm going to do is I'm going to integrate everything that has the dt with it. So it makes my problem a little bit easier. On the left, I only have y's, so that's going to give me y equals. Now, on the right, this is going to be a little weird, but remember, 8 can come into the front. Okay, so I can put that 8 in front of the integral symbol. And then the square root of t. Remember, this is t to the 1/2 power. So if that's t to the 1/2 power, add 1 to that. And when I add 1 to that, I get 3/2. Okay, so I'm going to have t to the 3/2 right here. Now, remember, I just want that 1 in front of the square root of t right there. So I'm going to divide by that exponent. And there's this first guy. Plus 6 times cosine t e sine t. Now, remember, just like we said a second ago with e to the 6x, the derivative of e sine t, when you take derivative of that, that's equal to e sine t times the derivative of the sine, which is cosine. So look at this. I've got e sine t right here, and I've got a cosine t right here. That's the derivative of that guy. So this is going to be e sine t. Okay, plus c. Well, I can't leave this first piece looking all rough like that. So if I have a fraction in the denominator, I multiply by its reciprocal. So that's 2/3. So when I do 2/3 times 8, that's 16/3 times t to the 3/2 plus 6e to the sine t plus c. So there you go. 17, 18, 19, and 20, some differential equations and getting them solved down for you. Okay. If you have a problem with one of these, I would recommend that you rewind the video, pause it, try and work one out on your own, look for patterns, get to the point of the video where you need some help, see what happens, and then see if you can work some of these out on your own without ever looking up and getting any help. And once you can do that, it'll start to all click into place.